Hey guys, welcome back. In this video, we're starting to talk about logarithms. So when we think about logarithms, this is a completely new thing that we haven't done so far. We're really going to start by asking this question. What does the inverse of an exponential function look like? And we're going to kind of progress to what is the inverse of an exponential function. So starting with this question, I'm going to do this graphically and working through properties of inverses. So in order to do this, I am going to start by graphing my function y is equal to 2 to the x, or f of x is equal to 2 to the x. So I have to remember back to graphing exponential functions, and I see that there is no k value, so 2 to the x is always positive. This is going to give me an asymptote at y is equal to 0. And you remember that we always want to graph this and label it. So y is equal to 0 is my horizontal asymptote. That means that my graph is going to approach this line but not cross it. There were 3 values of the exponent that we said are good to plug in, and those are -1, 0, and 1. Those are just going to be my x values here because my exponent is just x. So if I plug in -1 for my exponent, I get 2 raised to the -1, which is 1/2. If I plug in 0 for my exponent, I get 2 raised to the 0, which is 1. And if I plug in 1 for my exponent, I get 2 raised to the 1, which is 2. So I'm going to go ahead and put a few right? So now that I have that, I've got the point 0, 1. I have the point 1, 2. And I have the point -1, 1/2. And when I connect these, they're going to go up this direction, and they're going to approach the asymptote going this direction. So there is my exponential function. This is f of x is equal to 2 to the x. So there is my function. The domain of this function is all real numbers, so -infinity to +infinity. And the range of this function is 0 to +infinity. So now that I've got that down, I need to be thinking about the inverse function. So if we remember the inverse, to find an inverse function, we need to switch the x and the y for everything. So that's kind of the basis. So all of these x values will become y, and all of the y will become x. So this ordered pair -1, 1/2 will become the ordered pair 1/2, -1. This ordered pair 0, 1 will become the ordered pair 1, 0. And this 1, 2 will become the ordered pair 2, 1. So basically, I am switching these to get my ordered pairs for my x and x and f inverse of x. Okay, so the next thing is that all of my x's become y's, all of my y's become x's. That's going to apply for this asymptote as well. So this asymptote is now going to become x is equal to 0. All of the y's in my original function become x's in my new function. All of the x's in my original become y's in my new function. So then that also applies for the domain and the range. So the domain of my original is the range of my new. The range of my original is the domain of my new. So what does this look like as a graph? So my asymptote is now at x is equal to 0. And I have these points. So I have 1/2, -1. I have 1, 0. And I have 2, 1. So my graph looks like that and like that. So a couple things I want you to note. This has a domain restriction instead of a range restriction. This has an asymptote at x equals 0 instead of y equals 0. But if I were to graph the line y is equal to x, you can see that it is a mirror image across that. So this is the inverse. In our next video, we're going to get into a few more of the details about this.